Welcome everyone to the very first session of this PLM Foundational webinar series. In today's session, I will be taking you through the Teamcenter CAD data management capabilities. By the way, I'm Pradeep Peter. I work as a solution architect with Tata Technologies Business Development Group. So we all know that design changes are costly. When we talk about design data, it's not just a single part or assembly 3D CAD file, right? There are a lot of things associated with it, like drawings, GD&T, maybe assembly and structural simulation files, and motion simulation files, material spec, all sort of data that's attached or related to the 3D CAD file. Now, in a typical unmanaged environment, all this data is scattered across different user hard drives, or at the best, at a central network drive, right? So there is no real relations established between these different file types in an unmanaged scenario. With Teamcenter, we can store and manage this wide variety of design data in a same location or source, and we can establish the right kind of relation between these files. That way, we can do a impact analysis before committing to a costly change. Not only that, once we commit to a change, we can track and ensure that we update all the related documents and artifacts as part of a committed change. Now, in the next 30 minutes or so, what I'll be doing is I'll be taking you through the challenges we face in this area. Then we will look at the leading practice in the industry. Then we will see how Teamcenter implement that leading practice and provides a solution to address the challenges. And finally, we will wrap it up with the benefits of this. Starting with the design data management challenges in today's global heterogeneous CAD environment, the first challenge can be, how can I manage the functions, processes, and the dependencies associated with my CAD data? Or how can I enhance the design process by sharing and visual collaboration? Now, the collaboration both within my internal teams, say the supply chain or manufacturing or service, right? Or the collaboration between my external teams like vendors and partners. In another way, how do I bring in folks like supply chain, manufacturing, or even service upfront in the design cycle, and so that they can add value to the design cycle and help to reduce errors and minimize rework. In another way, how do I derive more value out of my 3D CAD data, at the same time ensuring that my intellectual property is protected when I collaborate with my external teams like partners and vendors? Another challenge can be, how can I have continuous visibility into design changes? Now, the leading practice in the industry is to store and manage this heterogeneous data in a single, synchronized and structured format using tools like Teamcenter, so that users can search and find the information they are looking for and use it for sharing and collaboration for value generation. That way, the teams across the world work as a single team, even though they might be separated by geography, location, and even at times organization. But everyone is working together, developing that single successful product. So in today's global distributed product development environment, we are seeing more and more of multi-CAD. Now, When I say multi-CAD, it can mean different things for different people, and the definition can change from one organization to another. At the very basic level, say a company is using more than one CAD system to develop or design independent products. Say they are using NX to develop product A and SolidWorks to develop product B. All they probably want to do is to store this NX and SolidWorks data in the same location with a consistent revision control, access control, and process control, right? So that's my discrete product design scenario, which is really a mini CAD scenario, okay? Then I can move up to my hybrid product design, where I'm going to use parts or sub-assemblies created in more than one CAD system in a single assembly. For example, I have NX and SolidWorks data in product A itself. Now in this case, for me to visualize the product A completely, I have to visualize NX and SolidWorks data together, maybe using the lightweight JT format. So that's my hybrid scenario. At the high end, we have the in-context product engineering, wherein I am visualizing the CAD geometry created in one CAD system, say NX, in another CAD system. So what I'm going to do is I'm opening NX CAD geometry in Catia. I'm not only visualizing NX and Catia together now, I'm going to create or edit Catia geometry in the context of the NX CAD geometry. So that makes my in-context product engineering. We will see more details about this in the subsequent slides. Here is another way to look at it from a value capability standpoint. So my discrete product design, which is nothing but many CAD tools scenario, falls at the bottom of my value capability spectrum. Obviously, the design in context comes at the top of it. Now getting a bit more detailed into these scenarios. So starting with the many CAD tools or the discrete product design scenario, like I said before, we have independent CAD assemblies from different CAD systems in the scenario. Yes, they are not connected logically or geometrically, but they still need to be managed, right? So we need to have a consistent revision control, access control, and process control to manage these many CAD assemblies. We don't want to have a different change management process for SolidWorks as compared to SolidWorks or Inventor, right? So with Teamcenter, we can have a consistent process to manage this many CAD data. Now moving to my real multi-CAD scenario, like I said before, in this one, I have a product or an assembly which uses part or sub-assemblies designed in different CAD format. In this case, I have an assembly created from Solid Edge, SolidWorks, and Inventor parts. Now in Teamcenter, this is a single assembly, right? Connected all the way from bottom to top, right? Now, what I want to do is I want to visualize this entire assembly in the same product structure context. How do I do that? I use the lightweight JT representation of this CAD geometry to visualize that together inside Teamcenter. Now, for people who are not really familiar with JT format, it's a lightweight representation of the CAD geometry. It's an ISO standard. Now, the good thing with JT is that you don't have to have a CAD tool to visualize it, right? So folks like supply chain or manufacturing or even service who don't have access to a costly CAD license can use JT files to visualize the product, right? Now, I can not only visualize the entire assembly together, I can also do all the standard bill of material operations I can do on any other bill of materials in this case, right? Even though it's a hybrid assembly, I can do all my standard bill of material process inside Teamcenter, like a cost roll-up or a weight roll-up, or creating a flat bill of materials, doing some mockups and stuff like that. So all those things are possible in this multi-CAD scenario. I'm sure you can appreciate the need for a multi-CAD in today's design world when we have design teams, different design teams from different locations, probably using different CAD systems, right? Yes, all of them are actually contributing to that single successful product. And at times we even have some carryover parts from some legacy CAD systems we no longer use, right? So that kind of explains you the need for a multi-CAD in today's design world. Now coming to my design in context scenario, in this case, I'm not going to use Teamcenter Viz to just visualize the JT files together, right? What I'm going to do is I'm going to open the geometry created in one CAD system in another one, right? In this case, in this example, I have an assembly consisting of NX, ProE, and Catia files. Okay, so what I can do is I can open the geometry created in ProE and Catia directly inside NX and then continue to do my design work inside NX. So that makes it a design in context. Okay. Now, to work in this kind of an environment, we need to have a primary design tool selected, which has to be one of ProE or Creo, NX, or Catia. The reason being, these are the CAD tools that can open JT files directly in that. By the way, these CAD systems uses JT file to open the CAD geometry created in another CAD system. We will see a demo of this later. Now, coming to the Teamcenter solution for CAD integration, Teamcenter has integration to almost all commercial CAD systems, including competitor CAD. So we have integration to NX and SolidWorks. Then we have integration to ProE, Catia, Inventor, AutoCAD, and SolidWorks. Now, Teamcenter integration to all these CAD systems are foundationally equal, or we have same or similar capabilities across the board for all CAD integrations, including check-in, check-out, directly searching for the CAD data from the PDM system, open, save, fast changes, right, and automatic update of part and assembly and drawings. So all these functionalities are kind of common across the board. Now, another good thing is that for us to do all these operations, the CAD users don't necessarily have to log into Teamcenter, which is the PLM system, right? They can do all this directly from their favorite CAD system. So that is very important from an adoption standpoint. This means the users can start using PLM with very little or limited training, and they can always continue to be in their CAD system. That's where they are more comfortable, and that's where they are really more productive. Okay. Now let's get a bit more detail and see the highlights of each CAD integration. Starting with NX. Obviously, NX has the most rich integration with Teamcenter. The reason being, both are from Siemens, right? So with NX, we have broad access to Teamcenter information and process directly from NX. We can navigate, browse, and do advanced search on Teamcenter data directly from NX. We can even do reuse library searches, classification searches, and stuff from NX. So as a next step, we will see a quick demo of the NX integration to Teamcenter. So let's assume that I have an assembly say a pump assembly managed inside Teamcenter. For people who are not really familiar with Teamcenter interface, this is how my Teamcenter interface look like. Pretty much like any Windows application, we have the file pull-down menus, the toolbars. On the left-hand side, I have my navigation pane where I have my quick links, history files, open items, my favorites, and shortcut to my applications, pretty much like Internet Explorer on the left-hand side. Then I have my data pane where I can, in this case, I'm seeing my bill of material for the pump assembly. So in this one, I can expand, collapse the pump assembly bill of material. On the right-hand side, I can even visualize the complete pump assembly, right? By the way, what you're seeing here is the lightweight JT representation of the pump assembly, right? So you're not really seeing it in the CAD. So think about it. Somebody from supply chain logging into Teamcenter, they can see this pump assembly without really having the CAD system installed on their laptop, or without having a costly CAD license. Okay. Now this is how the pump assembly looks like in Teamcenter. Now let's see the CAD Designers World. Okay. Now for a CAD designer, if they want to make some changes or do some design work on this pump assembly, they can go and search for this pump assembly directly from NX. So if you see here, I am doing an asterisk 55 search. So I know the part number of this pump assembly. So when I search for that, it showed me the result, and I'm going to open that. Okay, I'm not at all logged into Teamcenter. I'm doing it directly from NX. Okay, now I open my pump assembly. As a next step, probably I want to add a new cylinder head for this pump assembly. Okay, so in this case, I want to create a new component and add to the assembly. Let's see how we do that. So what I did is I click on a new component button. So it actually brings up the different seed parts available in the system, based on which I'm going to create a new part. So I can have different seed parts for metrics and inch. It's a part template. Okay, so I'm going to name it as a cylinder head. And you can see that that cylinder head new part got added to the assembly navigator of NX. Now I can do my standard design to create the geometry for the cylinder head. That's what the CAD designers are best at, right? So they can just quickly go and design this cylinder head. They do their magic, and we will have the cylinder head ready. Okay. Now I want to create, I created the 3D design for the cylinder head. Now I want to create a new drawing for that. Now again, right from the NX, right? Now when I click on a new drawing, it is actually showing me the different drawing templates available for me in the system. Now I can configure as many templates I want depending on my organization needs. So I'm going to select one of the template and going to create a drawing for that. Now this drawing template came with a title block, right? And with some of the data already populated from Teamcenter, like the part numbers, the part name, when it was created, who created it. So all these are small but important productivity tools. The CAD designers don't have to go and type these things in, and it also helps to reduce errors, right? Now I'm adding different standard views for the template or for the drawing. Then I'm going to save it back to Teamcenter. Now I saved everything back, so the CAD designer is done with his or her work. Now let's see how that data got stored back inside Teamcenter. Okay. So you can see that the new cylinder head I created got stored under the new stuff folder, right? Uh, Now, when I saved it back to Teamcenter, it also saved a lightweight representation, which is the JT file of that cylinder head, to Teamcenter. Now think about it. Anyone other than the CAD designer who is logging to Teamcenter can now see this cylinder head. They can not only see the cylinder head, they can even interact with the cylinder head, meaning they can go and section the cylinder head, take some measurements, take some pictures for the documentation. So we are we are kind of enabling the downstream folks to leverage this CAD data for their day-to-day activities so that they can derive more value out of the CAD. Okay. Now it's not just the 3D CAD part file that got saved into Teamcenter. We also created a CGM of the drawing. And now again, people who don't have access to CAD can look at the drawing. Okay. So that was about creating a brand new part from scratch and saving back to Teamcenter directly from CAD, in this case NX. Now let's take a use case of searching for an existing information and using that in the design. One thing we want to encourage in a PLM environment is reuse of existing data so that people are not reinventing the wheel, right? So in this case, I want to use a bolt for my cylinder head. So let's see how I do that. So I can search for a bolt, right? So it's showing me the existing standard bolts in my system. So I can take one of that and use in my assembly, okay? So I did my design work to add the bolt. So I created a new part in the first one, then I used an existing part in my pump assembly. Now let's take a use case where I want to create a new crankcase for this pump assembly, okay? Now, obviously, I don't want to start from scratch, right? What I want to do is I want to start from an existing crankcase, make some modifications to it, then save it as a new crankcase assembly. Let's see how I do that. So I'm going to take my existing crankcase assembly. So as a designer, I'm going to do my design magic, right, to model a new crankcase. So now I'm done with my design work. Okay, I created a new crankcase. Now I want to save it as a new item, right, or a new part inside Teamcenter. So I'm going to say save as a new item, give it a new number and revision ID, right, and give it a new name, right. And it is saying me that I have to actually update the drawing too, and I'm doing that. So what I just did is I started from an existing part so that I'm not reinventing the wheel. Then I leverage that existing design to create my new design with some minor changes and saving it as a new part. So that's what I did. Again, that new part got saved inside Teamcenter, right? Just like the previous case, a lightweight JD is also created, and obviously a drawing file is also created for that. Now, let's say I want to attach a lift eye to that crankcase. Now I'm going to again search for an existing lift eye based on a keyword search, and it's going to show me the existing lift eye in the system. I can even see a preview of that and make sure that's the one I'm looking for, then use that in my assembly. Okay, so I'm going to align that, do my CAD design work, and then my assembly is gonna be complete. Now, once I am actually done with all these changes, right, I'm done with my new assembly. Now, I'm going to save it back to Teamcenter, which is going to be my final repository, right? Now, when I do that, I don't want to save it to the existing revision. In this case, I want to create a new revision because I made some substantial changes. So Teamcenter allows me to save it as a new revision. Okay, so earlier the revision number was A. Now when I selected the create new revision option, the revision number automatically got bumped up to B. Now I'm going to save it as revision B inside Teamcenter. Okay, now obviously it's asking me to update the drawings too, and I'm clicking OK to that, and it's going to get stored back inside Teamcenter. Okay, so this is my final pump assembly that got saved inside Teamcenter as revision B. So if you see at the very bottom, we have the three things we have done from CAD reflected inside Teamcenter. So I added a new cylinder head by creating a brand new part. It's actually there in the BOM. I added 12 counts of the head bolt, right? That's there in the BOM. And I also added a lift eye, right? That's also in the BOM. And you can also see the same thing got reflected in the viewer pane. So my JT is also updated based on that. Okay. So that was a quick demo on the NX integration capabilities to Teamcenter. Okay. So moving on to Solid Edge. Solid Edge also has a similar foundational capabilities. We can do a secure vaulting of all the standard Solid Edge documents with access control inside Teamcenter. We can search for PDN database, in this case Teamcenter, directly from Solid Edge, right? We also have some assembly manipulation functionalities are directly available from Solid Edge, like the integrated revision and release management, the ability to configure new assemblies by cloning or revising existing ones. Pretty much similar to what we did for NX, okay? Now, moving on to Catia, if you remember, Catia is one of those CAD systems that supports design in context, meaning I can open the geometry created in another CAD system, say NX in Catia, okay? So let's see a quick demo of that. Okay, so now I'm back again in Teamcenter. So in this case, I have an assembly modeled, subassembly modeled in NX and another subassembly modeled in Catia. Let's see how we connect that together and create that hybrid assembly or a multi-CAD assembly, okay? So to start with, I have an NX part stored inside Teamcenter. Let's see how that looks like. So it's really a subassembly from a aircraft landing gear, right? So that's actually created in NX. Let's open it in NX and see how that looks like. So this is a NX assembly modeled in NX, right? Stored inside Teamcenter. Now let's open a Catia subassembly, right? That's the tires or the wheels of the landing gear. Again, and that's stored inside Teamcenter, right? We can visualize it in the JT format, and we can also open it in Catia and see how that look like. Okay, so this is the Catia wheel subassembly. Now, what I want to do is I want to create a single landing gear assembly consisting of this NX subassembly, which is the NX subassembly and the Catia wheel subassembly. Okay, so I'm going to create a product inside Catia, right? And I'm going to insert the NX subassembly, right? So how I'm doing it, I'm going to Teamcenter and say load it in Catia, okay? So when I do that, it's going to bring in the CAD geometry that I originally created in NX directly inside Catia, right? So this CAD geometry was initially designed in NX. Now I opened it in the Catia, okay? Now let me pick the Catia wheel subassembly and load it in Catia 2. Right. Obviously, I need to do the positioning if I haven't used a global coordinate system with the workspace is completely defined. If I in this case, I have to do the alignment work, and the assembly is aligned now. Now let's see how Catia opened that NX file. Okay. Now if I go to the Catia manage representations for the wheel subassembly, it opened it as a Catia part, obviously because that was created as a Catia design originally, right? Now when I go to the NX, let's see the same thing for the NX subassembly. So when I look at the NX assembly, right, it's not the .prt file that got opened here, right? It's the .jt file that got opened here. So behind the scenes, Teamcenter uses the JT files for the design in context scenario. Okay, so it's the JT files that get opened in a design in context scenario in another CAD system. Okay. So that was about the design in context scenario, and a quick look at the Catia integration. Okay. Moving on to the Pro Engineer or the Creo. Again, all the standard functionalities we have seen so far is available with Pro-E or Creo 2. On top of that, we have the ability to manage the simplified refs, and we have the family tables optimized for performance inside Pro-E. So let me show you a quick demo of that so that you can get a quick look and feel of how the integration works. In this case, I have an engine assembly managed inside Teamcenter, right? Now let's see how I am going to open that engine assembly inside Creo and make some changes. So in Pro or Creo, I have a Teamcenter button directly inside my CAD tool. So from a CAD user standpoint, they don't have to log into Teamcenter, right? They can come here, they see the Teamcenter menu right inside their CAD tool. They click on open. Then they can search for what they're looking for, right? So and they can do some smart searches with asterisk. So once I search something, right, it shows me the result. When I select on that, it shows me a quick preview of that part to make sure that that's the one I'm looking for, right? And it also shows me some of the attributes or the properties in the Teamcenter system. Again, help me to easily locate the part I'm looking for, right? If it shows me a different release status, I can say, hey, this is not the one I'm looking for. I'm looking for a production part, okay? I can also do a quick where referenced from this menu itself. So if I know a component and I want to find the assembly where it belongs to, I can do it right from the open dialog. Okay, so I can select the assembly I want to open. Again, for the assembly also, it will show me a quick preview and show me the properties from Teamcenter. So in this case, I'm going to open that engine assembly, right? And I can expand, collapse the bill of material or the product structure, right? And then I can open it. And then I can, once I open it, it's my pro here, right? From a CAD user, that's what they are comfortable with. That's where they are experts on, right? So they can do all the design work they want to do, okay? So in this case, they're going to take this component and make whatever modifications they want to make. Right? And then they can save it back to Teamcenter, right? So when they save it back, they can either check out an existing revision or create a new revision, or if they want, they can create a brand new part just like we did for NX, okay? So the behavior or the integration is similar across the board, right? So if a user know how to use integration for one CAD system, they can easily, do the exact same thing for other CAD integration too, okay? And I also have an option to create a JT file when I save it. So once it's actually saved back to Teamcenter, just like we had for NX, a new revision is created and a lightweight representation of that component is created inside NX, inside Teamcenter, right? So that people who don't have access to CAD can use it for visualization and to do their work, right? I can also create a new drawing or a brand new part. So in this case, I'm going to create a new port head. I'm going to do my 3D design. Then again, those are standard Pro functionalities. I can create a new drawing, right, with the right drawing template established. It's again, see here, again, it's showing me the templates available, just like it had shown me for NX, right? So I can select the one I want to select and then click OK, and it will show me the drawing template with some pre-populated views and a pre-populated title block, right? Exactly similar to the NX. Or Catia for that matter, right? Everything has these standard basic functionalities. So once I'm done with my drawing, I can save it back to Teamcenter, right? And once I save it back, again a JT and a CGM will be created, which I can use to visualize. Okay. So that's pretty much about the Pro integration user interface and the functionalities. Now let's move on to the next one. Moving on to SolidWorks, again the same standard functionalities available. The user interface is almost exactly similar to the Pro or Creo integration interface. On top of that, we have the SolidWorks toolbox support and some advanced attribute mapping capabilities between CAD and Teamcenter. Okay. Moving on to AutoCAD, again with AutoCAD, we can create and edit AutoCAD drawings and assembly relationship inside Teamcenter, right? We are storing and managing the data inside Teamcenter, but doing all the activities directly from the CAD, okay? We have a bidirectional transfer of title block text to and from Teamcenter. That's about the attribute mapping. And it supports all the standard AutoCAD documents, and we can also save the JT files for AutoCAD part models, okay? Pretty much similar to our other CAD systems. Coming to Inventor, in case of Inventor, let's see a slightly different use case, right? All along I was showing editing everything from NX itself, everything from the CAD platform itself, right? So that the CAD users can always stay in CAD itself, right? Now, in this video, what I'm going to show you is I'm going to edit a product structure from Teamcenter instead of CAD, and we will see how the changes are getting reflected in the CAD, okay? So I have a fork assembly managed in Inventor, managed inside Teamcenter, modeled in Inventor. So what I'm going to do is I'm going to replace these fork braces, right, and fasteners. Then I'm going to add a new coupler. And all these things are already modeled and available inside Teamcenter. What I'm going to do is I'm going to make these BOM changes directly from Teamcenter as opposed to a CAD designer making that changes. Okay. So let me go back to Teamcenter, right? So this is my original bill of material, right? Wherein I have the components to be removed, and what I'm going to do now is I'm going to multi-select all the components I'm going to remove. So I'm going to select the brace, right? I'm going to select the fasteners, and I'm going to remove it, okay? So now I'm going to add the new components directly from Teamcenter. So again, I can search for the ones I want to. If I know the part number, I can search for based on that. If I know the part name, I can search based on that. If I want to search based on some other attributes, I can do that too, okay? So I inserted the coupler. I'm going to insert the space bar. You can see at the very bottom those two things getting added, right? The slide coupler and the space bar got added. And if I want to, I can even add a non-inventor part to this bill of materials, like some documents and maintenance manuals if I want to, okay? So I'm going to do that too. So this is a summary of what I did. We removed some parts, added a couple of parts, and then I even added a couple of non-CAD items, okay, to the bill of material. I'm going to save it from Teamcenter, right? I'm doing all this from Teamcenter, right? I'm not in CAD anymore. Now let's see how Inventor integration is going to handle it, okay? I'm going to open my assembly, right? I can search or I can even browse the Teamcenter folder structure, right? In this case, I'm going to browse for it. I know my assembly. I'm going to open it. So when it's asked me, you know, which one to open, then when I open it, it's actually telling me, hey, something got modified from Teamcenter. Do you want to reload it, right? So I'm going to say yes, and it kind of shows me the summary of the changes that happened, right? I'm good with all those things, right? So the new components got added, right? Obviously they were not positioned. Now if I have to come to CAD to position it. Then as a CAD designer, I can position it. So the important point here is that I can make changes not only from the CAD system that will get reflected in Teamcenter BOM side. I can even make changes from the BOM side, right? For something like a top-down design concept where people who, you know, or product managers or somebody else who really don't want to work with CAD, they can go and make some BOM changes, and the CAD designer can then take over, right? So it gives that kind of flexibility too. Okay. So now finally let's look at the benefits of all what we have seen so far. And the number one benefits being the faster product launch cycles, right? Enabled through the design anywhere, build anywhere philosophy, supported with the interoperable high performance design collaboration tools, whatever we have seen in the last 30 minutes or so, right? Then we have the cost and overhead savings, realized through the reduced time to locate, validate, and share design data, right? Users don't spend too much time searching